Hello students, in this class we will see triangles very important theorem that's called Thales theorem or BPT, basic proportionality theorem. This is very important theorem. This will be asked many times in the exams. Please concentrate and study well. 4 marks will be in your pocket. What does this theorem says? Let's see. Statement will be asked prove in the question itself. You have to take that as a statement. Before that, let me give introduction to theorem. Theorem will have 5 elements basically. Statement, that's also called give a statement, which is which will be asked to prove that. For example, in this statement, in this case, it's a line drawn parallel to one side of a triangle to intersect other two sides in distinct points. The other two sides are divided in the same ratio. This is a statement. Means they'll ask prove that a line drawn parallel to one side of a triangle to intersect other two sides in distinct points. The other two sides are in parallel, divided in the same ratio. That's a statement. From this statement, we will have some information like given and to prove. Okay. So those two forms the other two headings. Given, it means there is a triangle, there will be a line parallel drawn parallel to the one side of the triangle. That's the given. Check out. In triangle ABC, DE parallel to BC means in this question, ABC is a triangle, DE is a line parallel to the one of the side BC. This DE intersects AB at D and AC at E, which are two distinct points. That is inferred from the statement. To prove means statement will have the proof statement, proof part of the theorem. The other two sides are divided in the same ratio. Means which sides to be taken? Means here the one which is parallel, the line is drawn parallel to the one of the side. Leaving that side, the other two sides are divided in the same ratio. What are the other ratios? Means AD by DB should be equal to AE by EC. Remember, AD by DB should be equal to AE by EC. That is the part that we need to prove. Okay. I'm repeating. Given will be triangle ABC is a triangle, DE is a line parallel to the one of the side BC. This DE intersects the AB at D, AC at E, which are two distinct points. To prove, the other two sides are divided in the same ratio. That is, AD by DE should be equal to AE by EC. Okay. Then, this part, the other next part of the theorem is a construction. This construction may be optional in some of the theorems. Okay. But in this, it is required. What's the construction we want here is, we join the BE and DC. Means the line which is drawn parallel to BC, we join the vertices D to C and B to E, the lower part you can see here. Okay. Then the other part of the construction is, we are drawing the line EN perpendicular to AB, means which is also perpendicular to AD, and DM perpendicular to EC. Okay. I'm repeating. EN, draw EN perpendicular to AB and DM perpendicular to AC. Understood? Now if you observe, there is a triangle ADE which has a height. There are two heights, EN and DM. And there is a triangle BDE which has a height EN, because BDE is a obtuse triangle that will have height outside the triangle. So for the triangle BDE, if you carefully observe BDE, EN is the height, and CDE, DM is the height. Check out. Okay. So since we want the ratio AD by DB should be made equal to AE by EC, we have to use area of triangle concept here. Okay. Area of triangle, just check out. Area of triangle ADE is one side, one time I'll take ADE and DBE, the other time I'll take ADE and CDE, the that sides. Okay, what happens? Let's see. Area of triangle ADE is half into base into height. ADE base is, once I made AD as a base, height should be standing on the base, remember. So area of triangle ADE is nothing but a base, half into base is AD into height is EN. Okay, see what I have written. Area of triangle ADE is half into base is AD and height is EN. Check out, height is EN. And area divided by area of triangle BDE. If I want to take base is BD, what is the height standing on BD? It is not height is not standing on the BD itself. It is an extended BD, because in a obtuse triangle height will be always outside the triangle. So the extended part of the base will have a height. Okay. So using this knowledge, area of triangle BDE will be half into base is BD into height is EN. Same thing I have written. Check out. Half into BD into EN. Clear? So in this one, half get cancels. BD, EN get cancels. We get AD by BD. Okay. This is, we call it as 1. Similarly, we take the other two sides triangle, like area of triangle ADE. Now I'll make AE as base and DM as height. So half into DM in base, base means AE into DM, which is one ADE it is. Similarly, area of CDE I will take. CDE. What is CDE? Area of triangle half into base is EC, height is extended EC will have DM height, right? DM height. I'm repeating, just check out. Area of triangle ADE is half into AE into DM. Once first time we made AD as a base, so EN will become height. Now AE we are making it as a base, so DM will be height. So next area of triangle CDE is half into base is EC and height is DM. Check out what I have written here. Area of triangle AD is half into AE into DM. Area of triangle CD is half into EC into DM. Extended EC will have the DM joined. If you check out, extended EC will have the height DM. So with this one, again the common things will go out. Usually we should not cancel in algebra this geometry thing. I'm just depicting you, I mean showing you how I got AE by EC. TE DM cancels. We should not cancel it, remember. Okay. Now, okay. Now from 1 and 2, if you check out the two proof part, we have already arrived at that point. AD by DB equal to AE by EC. Check out. AD by DB or BD both are same. AE by EC both are already available. So to make RHS equal, we should make LHS should be equal. How LHS? Check out. LHS is what? Area by AD by area by DBE, area by ADE by area by CDE. So ADE numerator also same. So only thing we want to make BDE and CDE areas are same. Means BDE and CDE. Where is CDE? This CDE. BDE and CDE area should be equal. Means LHS will become equal. How do we prove that? Area of BDE and CDE are equal. If you remember, in the 9th standard, we have studied if two triangles are on the same base and between the same parallels, their areas are equal. So for us, it is now E and D, B, C. These two triangles are on the same base. What is the base? DE is the base. DE is the base. What are the parallels? We know from the given DE and BC are parallels. So these triangles BDE and CDE, they are on the same base DE and between the same parallels DE and BC. DE and BC. Therefore, their areas are equal. That is a concept which we learned in the 9th standard. So the same thing I'm writing here. Check out. Now, area of triangle BDE and CDE are on the same base DE. same base DE, right? Like this it was B, like this it was C. BDE and CDE are on the same base DE and between the same parallels DE and BC, therefore their areas are equal. Okay. Now left hand side all are equal. Therefore right hand side should be equal. So, I'm calling this as 3. Therefore from 1, 2 and 3 we get, since LHS are equal, RHS should be equal. This is a mathematical concept. Therefore we just write what is to be proved once again. AD by DB equal to EAE by EC, hence proved. Remember, we are using two concepts here. Only area of triangle concept, one thing. Secondly, the concept which we learned in the ninth standard, that is area of two triangles which are on the same base and between the same parallels are equal in area. Okay, so that concept. Believe me, this is 4 marks theorem. It will be in your pocket if you study it well, practice it well, very easy. Take ratios of two triangles, areas of two triangles, write half into base into height. Other two triangles on the right side, half into base into height. You get to the ratio directly. Part now is to make the left hand side equal. In the left hand side equal already, also we have ADE, ADE in the numerator which are same. Only thing is CD and BD we should make it equal areas. So this concept gives us area of BD and CD are equal. Therefore, we get AD by DB equal to AE by EC. Okay, this is called Thales theorem or basic proportionality theorem, which is called BPT. Okay, it has many applications. Okay, we'll see that in the coming classes. But this is very important theorem. Practice well. Okay, thank you.